Okay, cool. So welcome everyone on this month's episode, which is Busy Java Developers Guide to Graal. And we are still virtual, as you can see, and I believe it will stay like this, at least till the end of this year. And let's see what will happen next year. So who we are and what is CJUG? We are a community around the Java ecosystem. We are trying to learn and contribute to Llvm technologies. And we are also trying to help in mentorship or finding career opportunities. So if you're hiring, please reach out to us. Or if you are seeking for a job, please see our job mailing list. It's on cjug.org. And we also want to have some fun and build things in the meantime. If this is your first time being here, please share the love and invite someone for our next event. And if you're interested in doing something for the Java community, please consider volunteering or speaking at CJUG. So you can reach out to us on Meetup, Twitter, or email, you choose. We have a very brief code of conduct, which is like, just please be nice to each other. And now we have over 2,200 members, which is, I believe it's a good number. But we also know that there are way more Java developers in the area. So if you know them, please let them know about us. I'm not sure if we have any upcoming events. I believe DevNexus just like announced that they will do a in-person conference next year. And as far as I know, maybe I will talk on the next event, but let's see about that. Logistics, this is an old slide. Hopefully you all know the Wi-Fi password and the location of the kitchen and the bathroom. And as Neward said, before, we are sponsored by JFrog. They keep us running. For example, this is why we can have a Zoom license. So thanks for them. And our speaker today. So there might be a slight chance, a tiny chance that you have heard about him, because he speaks at conferences all over the world and he writes regularly for a variety of publications. You can find his articles and books all over the internet. So our speaker today is the dude of software, Ted Neward. So Ted, I believe this stage is yours.
Wow, it's an intro like that. I mean, yikes. Who knows what we're in for? But you know, that's just like your opinion, man. All right. Just quick virtual show of hands. If you've heard of Grawl, Llvm, Grawl, the two terms seem to be a little bit synonymous these days. If you've heard of it, you know, give me some kind of a response. Chat +1 or a emoticon or show of hands. Got a couple of hands up. Okay. Has anybody ever like downloaded it, played with it? So like one person. Okay, cool. Because that is essentially my assumption for this particular talk, that you may have heard of it, but you've not spent any time playing with it. What I'm finding is a lot of people are kind of scared off by the fact that it's an Oracle Labs software package. Labs somehow implies to people that it's like academic or not ready for prime time or production or whatnot. That's definitely not the case, but I'm getting a little bit ahead of myself. What I want to do essentially is do a Llvm 101 kind of thing. I'm not going to dive real deeply into any particular aspect of it. I'm going to just, you know, explain what it is, where it is, how to get it on your machine, and point to some of the major areas in which Llvm has done some research. And in particular, the part that I get really excited about is the polyglot capabilities of Grawl. You know, we've often talked about the Llvm as being the one platform that runs anywhere. And then Microsoft really took that idea and said, oh, well, we're going to build multiple languages on top of this platform, right? Their version, which was the Common Language Runtime. But Graal actually has taken this notion of many languages on top of a singular runtime and really, really expanded it to the point where they can actually act as a drop-in replacement for some of the more popular scripting languages that you're familiar with. That opens up a lot of interesting possibilities once you know how to tap into that particular environment. Oh yeah, and by the way, Graal has figured out how to do an ahead of time compile on a JVM application and turn it into a native binary, which if you think about all of the dynamism that the Java virtual machine goes through, that in of itself is a really, really interesting aspect. So essentially, like I said, I want to just do kind of a general overview of Graal. If you've played around with it, if you've done anything with it, some of this, a lot of this will be redundant. You know, please feel free if questions pop up, please feel free to like unmute and answer them. I stand on no particular ceremony. You're not going to offend me if you pipe up and say, hey, I don't think that's exactly correct, Ted. When I looked at it last, it did this, that, or the other thing. Life's too short for me to be accidentally spreading wrong information. So Adam, I'm expecting you to hold me accountable because clearly you're the expert here and I am not. So let us move forward. That was a joke, by the way, in case anybody wasn't sure. So what is it? If you go over to the Graal VM website, which by the way is here, it says high performance JDK distribution. The high performance, particularly because what they're looking to do is they're looking to improve a lot of the machinery inside of the JVM. One of the biggest problems with the JVM for a long time, very bluntly, was the fact that it was all written in something that wasn't Java. Most of it was either straight C or very, very nice, cleanly architected C++. If you've never looked at the OpenJDK source code, I encourage you to do so. Even if you don't know C++, it's actually not nearly as much of a mess as you might envision. You know, it's a nice, Adam, nice. You get an emoticon back. There we go. Oops. There we go. Oops. So high performance from the standpoint that what they wanted to do is they wanted to make it easier for people to experiment with the JVM, for people to extend it, particularly around the areas of garbage collection. One of the things that we've seen over the years is that First Sun, now Oracle, has been constantly tinkering and experimenting with garbage collection, trying to get better throughput, trying to get better reclamation statistics, et cetera. But again, to do all of that, you had to be an expert in C++, because that's what the JVM was written in. Well, first we had some hooks that were introduced in the JVM back in the 1.4 timeframe. We had JVM DI, the debugger interface, and then we had JVM TI, the tools interface. That has gone through several revisions and deprecations. But again, those were all assuming that you were going to write something in C++ and bind to it through a native library. What Graal did was say, why do I have to write a JIT compiler in C++? Why do I have to write a garbage collector in C++? I mean, Java as a language is very, very similar. The fact that it doesn't compile down to native code shouldn't actually be a holdup. It shouldn't be an obstacle. So what they really went with was, we want to allow us to create high performance JDK extensions and improvements without having to do it in something that's not Java, to sort of create kind of a full loop, full circle kind of experience. Written in Java and other JVM languages, along with support for JavaScript, Ruby, Python, and a number of other popular languages. The full list, actually, this is not actually the complete list. There are a couple of other things that are here, but you can see they've got some of the popular ones. JavaScript, Python, Ruby, R. For those of us coming from a heavy data science background, Python fits into that as well. And then WASM, WebAssembly. As part of the JavaScript support for Graal, we can go ahead and execute WASM bytecode. One of the other things that it's in a future slide here, it also has support for LLVM. There was a research project from the academic world for many years called Sulong, S-U-L-O-N-G. See if Google, yeah, here we go. No, this is more recent. Sulong basically became a part of the Graal VM environment, but Sulong itself was around for many, many years. I remember looking at it a long, long time ago, before Graal was a thing. And they were experimenting with a lot of the, how could we cross compile, how could we do interesting, safe execution of native code, et cetera, et cetera. Well, Sulong got incorporated as a part of the Graal VM, which gives us the ability to take Llvm, the low-level virtual machine. Those of you who've never seen Llvm, this is actually the tool chain that Swift, Apple's iOS development language, is built on top of. And a lot of people have said, oh, well, virtual machine, that means it's just like Java. Not exactly. The whole point of Llvm is to make it a more standardized way of generating native executables. But it does produce a portable, they don't call it a bytecode, they call it a bit code format. And so, for example, the C-line compiler, C compiler, C, C++, Objective-C, this would compile to Llvm bitcode, which could then be turned into whatever particular CPU instructions, right? This is actually a very old pattern. Originally, back in the 70s, there was a Pascal compiler that did something similar to this, and then you would recompile it on whatever particular target architecture you were on. The fact that Graal knows how to execute Llvm bitcode is very, very interesting, because it opens up a whole slew. Yeah, Rust. There's a lot of different compilers out there, Adam, that are using Llvm and building on top of that as the backend for doing optimizations and so forth. So this is very interesting, particularly because to take Llvm bitcode and go to an ARM CPU architecture is pretty trivial at this point today. So it is very possible that we could be looking at a scenario where at some future point, we compile something, it's into Llvm bitcode, and Graal can rely on Llvm to turn it into a native Android or native iOS executable, right? Now, you already have the Android ecosystem that knows how to compile for Android, but a Java to iOS native solution would be really, really nice. There have been a number of attempts at doing sort of portability scenarios. I can't remember the name of it now, R something or other, did a Java bytecode to ARM instruction translation, but it was always a little, it was fragile in many respects. And the fact that Graal can do native images, in other words, we can take a Java implementation and turn it into something that is native to the target architecture, that's really, really interesting. It's very powerful, and it definitely opens up the idea of Graal as kind of a universal runtime, as well as opens up the Java ecosystem to be more than just running on top of JVM bytecode. Because it starts with JVM bytecode, it means that we're open to all of those different languages. So Kotlin, Scala, Groovy, etc. All of them are, because they can all run on top of Graal, they're all eligible to think about how we mix and match with all this other good stuff. So virtual machine execution engine, it is a drop-in replacement for Oracle Java 8 and 11. As a matter of fact, I think I just saw today that they dropped a new release which gives us Java 17 support. Yeah, let's see if, oh, that's a stream. We don't want to join the stream. The most recent, and I think my slides reflect this, the most recent version of Java that Graal was supporting was Java 16. But I believe the release that came out today is Java 17, which is nice. Maybe it's here on the blog. Yep, there we go. Java 17 support, right? Fresh off, that's today, folks. Fresh off the presses here, right? I'll talk about the different flavors of Graal in just a second. Let's see, pattern matching for switch expressions, sealed classes, getting access to all the Java 11 features, and compiler updates. Yeah, Okay, cool, cool, cool. Anyway, so they're definitely marching along and keeping this up to date with all of the changes. Usually they're a couple of months behind the standard Java release. So if Java 17 ships in January, then support for it in Graal will be somewhere in February or March, April at the latest. I've found the longest is 3 months. Usually they're pretty quick to catch up. But there is sometimes a window in between. Not that I'm finding anybody in the Java community is really like living on the bleeding edge right now. There are still a number of places I know that are still running Java 8 or are running Java 11. I haven't run across anybody that's doing 16 or 17. So let's see. All right, ahead of time compiler for Java. That's the native image tool, which we'll look at and play with. The Polyglot virtual machine, that's the part that I've been going gaga over. And then Truffle, which is the framework name for the Polyglot support. The Truffle framework is what gives us the implementation of Java, JavaScript, and Node.js, Python, Ruby, R, Llvm, and Llvm. But the Truffle framework is open such that you can actually hook into and create your own language and DSL implementations. This does not have a whole lot of documentation to it. Their basic model is there's the Java docs, there's a sample project up on GitHub, you go. And the assumption is that you know something about implementing a language. But this is the same framework that they use to do a lot of the optimizations that we see for some of these other languages. So it's definitely worth it if you're thinking about creating a language that's going to be anything other than a toy. It would definitely be something that I would strongly suggest you dive into. And all of this falls under the umbrella of the Truffle framework. We'll talk about all of these at some level as we go. There are a couple of different flavors of Grawl. Yeah, like I said, whoops, that should be Java 17 compatible as of today. But notice that it's still officially labeled as experimental. When we go look at some of these here, actually, let's not start with Java. Let's go with, I think Python is still officially listed as experimental. In a different version of this documentation, they would have a banner across the top here indicating whether or not it was experimental or considered alpha or considered production ready. The Grawl is a platform. Oh, go ahead, Adam. Plug shamelessly. Plug shamelessly, my friend. This is a safe space. No, seriously, unmute. Unmute and tell us what you wrote on. No? Come on. This is your time to shine, Adam.
Put a link in the chat.
All right. Let's see. Guides. Yeah. The documentation is, I mean, there's a lot of words here, but in many cases, it's hard to find a lot of the things. Let's see, language references, Python. Yeah, see, this is what I was looking for. This banner across the top indicating whether or not it's considered experimental or production ready, right? So a lot of this is definitely considered to be in varying states of support. From having talked to the folks that I know there, it seems like the intent is that they do in fact want all of these to become production quality, production supported, etc. But part of the thing is this is Oracle, and they do want to make sure that they get their money out of it. So part of what they've done with Grawl is they've actually broken it out into two different flavors, if you will. You can see here, there is the community, which is free for use, right? And according to the powers that be, will always be free. And then there's an enterprise license for Graal VM, which I believe if you use the Oracle Cloud, you can already, you can basically use Graal VM in the cloud for free. There we go. And if you have a Java SE subscription, or if your company has a subscription, then you're also able to use the Enterprise Edition. Practically speaking, I'm not sure what the difference is, with one caveat. The Enterprise Grawl comes with the G1 garbage collector, which remember is the one that Oracle produced that was supposed to get much better throughput, much better, much slimmer runtime size. The G1 garbage collector comes with Enterprise. I don't believe it's available with Community. There are a couple of other features, like with respect to how, like some of the native image support, which features are enabled and turned on or whatnot. For the most part, I think unless you're planning to put Grawl into your production environment, which I don't recommend right out of the box, you do want to spend a little time getting to know it and seeing how it will work. Same due diligence you would do with any new Java virtual machine. Community has pretty much everything that you need. So I would start with this version and then only move up to Enterprise if A, you want to give Oracle a bunch of money, or B, there is some particular feature of Grawl that you need that's only available in the Enterprise Edition. The other thing is, do you want to be Java 8 or Java 11? This is one of the two axes on this chart. Some companies are still Java 8. Some companies have moved up to 11. Or do you want to experiment with the Java 17 level support? Those are the three flavors that are officially out there. Now, obviously, if you really, really wanted to, you could go grab the Grawl source. This is all being developed out in the open, and you could compile it to any particular Git commit that you wanted. But for the most part, you just want to grab the binaries that are out there. I've personally been playing around with the 8 and the 11 flavors and haven't missed anything, unless there's a specific feature of the Java language that you were looking for that came in post Java 11, right? So if you're looking for implicitly typed variable declarations, for example, you're not going to get that in either 8 or 11. Okay. How do we get a hold of this? Let's see. Well, let's see. I thought, no, maybe I didn't. Yeah, I must have forgotten to put that. All right. So a couple of different ways to do this. One is you can download the binaries from the Grawl website. As a matter of fact, if we go to the Grawl, oh, sorry, not Grawl, it's Grawl VM. There we go. Let's see, here. So this is the Grawl VM Community Edition developer builds, right? You can see that they've got one for 8, 11, 16, and 17. Now this is going to be where under the releases section of GitHub, where you can get at some of these assets and so forth, right? So this is for all the developer builds, which is, again, those are dog food builds, not necessarily where you want to be. If you want to play around with it for the first time, I would suggest the Grawl VM Community Edition builds here. So this would be the version, I believe, this is listed as 6 months ago. So given that they just dropped one today, we should see a new one of these show up before too long. As you can see, they've got a bunch of them. You notice that these are all architecture specific, because we do want to, you know, if you're going to run on a particular platform, we want to make sure that you're using the right binaries for that particular platform, because this does involve a number of native pieces to it. The other thing that, you know, frankly, chasing these versions down, that's so 1990s. Package managers, container managers are much, much easier. Frankly, if you really, really just want to experiment and you don't really want to commit a whole lot of drive space to it, Grawl does have some Docker containers. Let's see, container images here. So you can always do a Docker pull and grab the Grawl VM CE latest, which again, presumably will pull the one that they just dropped today. And then you can shell into the Docker container and play around inside of there. That's one way to do it. The other way is to grab one of the Java package managers. I've been experimenting more recently with SDKman. This is kind of nice because it runs on a variety of different platforms. And then you know, so if I do an SDK, let's see, let's list all the different flavors of Java I have on this machine. So we can see I've got a couple different flavors of adopt OpenJDK. And this nomenclature here is a little bit weird. There's obviously different vendors of Java. And then in the adopt OpenJDK world, they have both the J9 virtual machine from IBM as well as the hotspot virtual machine, right? So that's what this is. This is the difference between 1601 from IBM or 1601 from Oracle Hotspot. There's version 11, 8. You notice that I have those 3 flavors installed. Notice I also have Grawl. I've got the 21.2 R16, right? So let's do this here for a second. Conveniently, since they just dropped a new version, I'm going to install it. And this is going to do the usual ASCII art to show download progression. Now, the nice thing about SDKman is you can have multiple installations and you can switch between them just by doing an SDK use and popping up that little descriptor phrase as to which one you want. Right now, since I have never played around with 17 and I'm not entirely sure what else would be broken, I'm not going to make it the default in this environment. I'm just going to have it on my machine, and then I can remove the older one if I choose or whatnot. But what this will do is this will create a .sdkman directory underneath your user directory, and then under there, all of these different candidates will be installed and stored and managed. Now, the Mac has its own Java home utility for being able to manage different flavors of the JVM. I haven't found that to be quite as seamless as I have SDKman, but that would work as well. You could certainly grab the Grawl downloads and pop them into the whack library, whack Java virtual machine directory path where the Mac likes to put JVMs. The key thing is you just need to make sure that the Grawl bin directory is on the path. Now, one of the drawbacks to doing SDKman is it doesn't recognize the fact that Grawl actually has a number of additional binaries to it that are not part of a standard Java distro. So, for example, let's see, let me go to, let me pop up in the window here. So you notice there's an SDKman directory there. So let's pop into that and go into candidates and go into Java. And let's go into 21.2.0.r16 Grawl. So this is, from this point further down, this is all Graal VM. SDKman has nothing to do with any of this. And inside of the bin directory, you see a whole bunch of things that we don't normally see as part of a JDK installation. For example, R. Should really be doing this on Talk Like a Pirate Day. Herb, Gem, those are all Ruby things. Grawl, Python, IRB, more Ruby. What Grawl has done is they have provided a number of binaries that will provide similar functionality to their non-Grawl equivalents. So for example, LLI, this is the Llvm bitcode interpreter, right? All of these, this will be implicitly a part of the path because they're here in the bin directory when SDKman installs it, which is nice. But there are potentially some other tools. If we go under languages here, so here, for example, we see JS, which is a JavaScript implementation, and there's a bin directory inside of here in which there is a JS tool exposed as well. So just be aware of the fact that there may be some tools that Grawl installs that are outside of your normal JDK. And if your package manager just does the standard aliasing thing, like they have Java under user local bin, and then that is an alias to someplace inside of where the actual Grawl is installed. These additional tools, because they're not part of the standard JDK, they wouldn't appear, they wouldn't be aliased. So you really want to make sure that the Grawl bin directory is on the path if you're going to start using a package manager. Homebrew, for example, when it installs Grawl, it's a cask install. So you will put it under /library/wherever. And Java Home doesn't manage any of the rest of these. The best way to test whether or not your Grawl installation works is to type GU. This is the Grawl updater. because now we have package managers inside of package managers inside of package managers. We've reached inception. Goo is a utility for managing the bits of Grawl. It is the Grawl component updater. And so Goo will tell us what's available from this edition of Grawl. So notice it's telling us that we're on version 21.2, which we are. Remember, that's the version that I came in here with, not the one I just downloaded. And we see, we swing this out a little bit, so it's, there we go. You can see that there are a number of those tools: Llvm toolchain, native image, Node.js, Python, R, Ruby, Wasm. These will need to be installed. They won't necessarily be there by default, or at least that used to be. Looking at the bin directory, it would suggest that they are there, but remember, I installed a bunch of these. Actually, let's SDKman, candidates, Java 21.3. Notice that this list is much shorter, right? Here we see Goo, but we don't see the Grawl Python. We don't see the Ruby, the gem, the ERB, etc. That's because all of those binaries were there because I went ahead and did a Goo install for each one of these guys. So when you get Grawl out of the box, you'll get the Java tools, but you won't get all of the other stuff, right? So you'll need to do a Goo list. This is what I currently have, Goo available, right? And so Goo install Python, which I've already installed. So does all make sense so far? Okay, I take silence to mean you are perfect in every way, practically perfect. All right. So let's see. So like I said, SDKman is the best one that I've found thus far. But however you want to get Grawl, get it to some place where it's on your system and the bin is a part of the path, and you can go from there. Okay. Now, as a drop-in, it actually works relatively well as a drop-in for a variety of these different languages. You know, it certainly works as a reasonable drop-in for Java. So if I do Java version here, you notice that it's reporting as OpenJDK 16, but then very quickly it shows that this is Graal VM 21.2.0. Okay. I've been running Graal as a drop-in Java replacement for a while. Now, granted, I haven't done anything in production with Java, so I'm not going to tell you that it's perfect for all of your Java needs, but it's so far been pretty good. It's been pretty reliable with some of the Java applications I've thrown at it. Excuse me. Again, if you wanted different flavors, like if you didn't want to support 16, if you wanted to do Java 11, that would again be an exercise in pulling down the right package from SDKman. Well, so notice if we wanted a 21.3 for release 11, and it looks like 21.3, at least not yet, hasn't supported 8. Oh, it looks like they've removed 8 from all of the official images. They used to have a 20.3.3.r8 or something similar. So it looks like they're moving away from 8, finally. Oracle is going to force people to move away from 8 and up to 11. Okay. All right. Anyway, let's see. So we were to run Python here, Grawl Python. Notice that it's not quite up to latest and greatest Python 3.8.5. Currently Python, last time I checked, was 3.8.10. But, you know, it's still Python. And if we do, let's see, IRB version. There we go. Yeah, that doesn't put a Grawl banner up. Yeah, it's definitely the one coming out of Grawl though. Now, a lot of these are listed as experimental. And I've already shown you guys the Goo tool. The JDK has all of the Java tools. There is an AOT compiler, which you will have to install by doing Goo install native image. We'll talk more about this in a second. The Node.js runtime is actually also a couple flavors behind. So if we do which node, notice it's coming out of the same Grawl environment. Node version 14.16, which is one stable release behind. Currently, Node is up to v16. Now, I don't know if anybody cares the difference between 14 and 16, but it is interesting to note that the Grawl folks are just a wee bit behind, a little bit further behind the other languages as opposed to Java. So let's see what else. The Llvm tool chain, which is currently at v10. The most recent Llvm versions are up to 13, if I'm not mistaken. Yeah, there we go. Llvm 13 as of the October 4th. That one is a little bit more disturbing. I'm not sure if they're just waiting for a convenient place to cut over and support a more recent version of Llvm or what the decision is there. But that one being 3 releases behind is a little bit more disconcerting to me. But they've got a lot of the same tools available for doing Llvm's execution, specifically the LLI interpreter and the LLD debugger. Those are the 2 big ones. Python, it's Grawl Python instead of Python 3. So it's not exactly a drop-in, but it's pretty easy to change any scripts if you needed to. And then there is support for a WebAssembly interpreter, Llvm. And this supports WebAssembly 1.0 and is actually baked in around some of the same support that they got for their JavaScript implementation, which is what Node.js uses as well. I don't know if anybody here does a lot of R. I personally don't. So it's hard for me to know exactly how close this is to the current state of the art in the R world. I've talked to a couple of people who say, oh yeah, as long as R4 is supported, you're good. So they describe themselves as supporting GNU R 4.0.3. So theoretically, we should be able to use R and RScript for doing R data frame-y kinds of things. Marcus notes in the chat, he ran into some issues with some R packages. That I think is going to be a pretty common theme for a lot of stuff. For example, if you do Grawl Python, there are a number of Python, I shouldn't say a number, there are a few Python packages that rely on native library, native extensions that I don't think will be flawlessly supported. Ditto for Ruby and JavaScript. There is still some native code. You know, there are some gems that when you install them, Ruby wants to grab the local command line C++ compiler and build. And that probably won't work out of the box. Now, the Grawl folks, they're looking, oh, that's what I forgot to put in this list. I forgot to put Ruby into this list. You work on a talk and then you discover later you forgot stuff. Oh, well. Anyway, you are going to find that there are going to be some places where Grawl is not going to be a perfect drop-in. And that's part of the reason you do the due diligence. Again, generally speaking, I'm not as interested in trying to replace C Python with Grawl Python. I'm more interested in seeing the ways that I can use the two simultaneously. Like, can I call to a Python library from my Java code? Can I call to a Ruby library for my Java code? Can JavaScript call into Java? I personally have been, I've been very, very bullish on the idea of Polyglot for a number of years. So like the scripting language API, JSR 223, that was one that I was always disappointed didn't get more interest in play, because I truly believe that one of the best things you want to do is figure out, let users, the closer you get to the users, the more I want to use a dynamic or a scripting language resting on top of a strongly typed foundation. And so the ability to interop across languages like this, particularly given, for example, Ruby's flexible syntax. Ruby is a great language for experimenting with DSLs. That's really where I think a lot of the power comes personally. One of the things that the rest of the world really likes, though, is the fact that Grawl can generate a native image out of a Java application. So if we have some compiled Java code, we can actually take it and run it through the native image tool. So make sure you've installed native image, which I already have. If you've got it, then you should be able to bring native image up. Notice it gives me a banner message telling me Run help if you want to see what all those help messages are. What this dude will do is this will take either a class file or a jar file, and it will essentially run it, sort of. It'll do a static analysis of the Java code, and it will build out a native image of the application so that you no longer need a JDK to run it, okay? So if, for example, let's go into native image here. So example.java, very, very straightforward thing, right? We're doing a string reversal, right? So very straightforward stuff. Ooh, it's so magical. Okay. Now, if I do native image on it, what's going to happen is this tool, which is not the world's fastest tool by any stretch of the imagination, because what it's literally doing is it's going to example, it's going to main, and then it's starting to spin through all the things that the JVM does. So all of the classes, remember the JVM is a very, very dynamic environment. Everything is loaded on demand. So an example depends on Java-lang object because it inherits from it. Okay, at that point, a class load occurs and we pull in Java-lang object. And okay, not object because it's part of the core bootstrap, but you get my point. We've got to go through and follow all of the references and figure out what additional classes do we need to have. In addition to that, it does a whole bunch of other analysis as well to figure out what the heap will look like. And because so much of this can be runtime loaded, right? Class.forename and friends. Remember, that's what we do every time we want to pull in a JDBC driver because there are no static dependencies otherwise. All of that has to be run effectively, or at least code analysis to determine whether or not this method could run. And so this guy will actually spin over your code multiple times until it actually gets to a relatively stable state. At that point, it says, okay, cool. Now I think I know what this thing looks like. I'm going to poop out all of the code into a text section and all of the data into a data section, drop that into a COF or an ELF executable. And what we end up with is example, like so. And it runs. Can you say something about the performance compared to non-native on Grawl or Hotspot? Generally speaking, it's not just me. Let's see, where is it? Wins. Startup speed is faster. That's the biggest win. That's the thing that everybody is going after, particularly with respect. Where you really see Grawl getting most of the press right now is around these microservices frameworks. Because for them, particularly when you're running cold, a cold start of a microservice can be a really big deal. And so getting that faster startup speed is definitely important to that world. So if you Google on Graal VM, for example, about 2/3 of the links will be in conjunction with some of these microservice frameworks. The memory footprint is supposed to be smaller. I haven't actually tested that myself. The packaging size is theoretically smaller. Well, let's see. Example here is 11 megs in size, which is certainly a lot bigger than example.class is. But when you consider that this example is statically linked and is standalone, it does not require any dependency whatsoever on an installed JDK. 11 megs to have a standalone executable, that is actually a pretty significant size difference, considering that the last time I looked at the full size of an installed JDK, JRE, et cetera, was in the hundreds of megs minimum. Yeah, those are where your wins are going to come from. Now, is this the world's most efficient way to run Java code? Not exactly. The garbage collector, because this is still all garbage collector. The garbage collector inside of the native image is not anywhere near as good as the one that ships with the JDK. And so the throughput and the latency of the garbage collector in the native scenario, not great. There is actually a way to, let me bring up native image again. you can specify which of the garbage collectors you want to use. They should have it listed here somewhere, at least they used to. Incomplete class path, auto fallback. There we go, GC equals value. Options for value, either the serial garbage collector, which is the default, or the epsilon garbage collector. You know, epsilon sounds sexy. I wonder why that's not the default, because that's the collector that doesn't actually do any collection. This is the garbage collector that will literally allocate but never deallocate all the way up until you run out of heap space and die. Now, you say, why on earth would I want to do one of those? For extremely startup time sensitive, serverless kinds of scenarios that are not going to last more than a half second, right? That's where the epsilon garbage collector can really be most useful. The other place, of course, that everybody loves to run the epsilon collector is when they're doing benchmarks, because it's amazing how fast your Java code can run when you don't have to do any garbage collection whatsoever. So it's not an all-win scenario. Now, one of the other things you can do is you can create what's called a fallback image, which is to say there are certain scenarios where if the native image tool cannot, if it can't do all of the static analysis necessary to find all of the code it needs. So for example, if at some point you spin up a URL class loader and you go and load some code off a URL, AKA an applet type scenario, that is not something that native image is going to be able to follow and understand. And so at that point, it's going to spit out a warning / error and tell you that it is abandoning the creation of a static image, and it is now building what it calls a fallback image, which is native code that still relies on an underlying JDK. So we're still doing some ahead of time compilation, but we will require a JDK to be present. So if we do this for our example here, force fallback. Yeah, so here, notice it's spinning out a warning. Example is a fallback image that requires a JDK for execution. Use no fallback to suppress image generation and print more detailed as to why a fallback image was necessary. Normally, this warning shows up if native image tells you it had to do it. I forced it by passing this flag in. So you would never use force fallback and no fallback in the same command line. Notice that the size is basically the same. In this particular case, I didn't need to do a fallback image. And, you know, it still runs the same, right? Now, one of the things, particularly if you go out and look at some of the slide decks that Oleg and some of the other folks from Oracle are doing at conferences, you will see a lot of time spent on benchmarking the native image versus the standard JDK image. And not surprisingly, the native image comes in winning for, you know, a variety of scenarios, right? They're really stressing the fact that the native image is a tool designed to try to address some of the traditional weak parts of Java, which is to say startup time being the biggest one. I can't tell you how many times I've heard people who are not particularly favored towards Java. Some of my .NET friends, some of my Ruby friends, oh my God, it takes so long for the Java virtual machine to get started. Seriously, if that's the biggest concern you have, I want your life, I want your job. That does not seem, particularly in a cloud-based world where we typically spin these things up and leave them running for quite some period of time. It doesn't strike me as a real hardship there, but you know, whatever, you do you. This addresses that. At the price of down the road, you pay for it because you don't get the, you know, the better throughput. You do get some additional latency because the serial garbage collector is not able to do as much stuff in parallel, right? This does work, by the way, for any jar-based code base. I've done this with some Kotlin applications. I've done this with some Scala apps. I haven't tried it with anything Groovy yet, mostly just for lack of time and because I have pretty good faith that it'll work. I mean, if it's JVM bytecode, it's JVM bytecode. Okay. If all the dependencies are not available, you either have to fall back to a JDK or you run the risk that there's going to be a runtime error that would crash the program. Either of these is a reasonable decision to make, or you figure out ways to make the dependencies more statically available. Go to that URL class loader, figure out which URL we want, pull that jar file down and put it into the path so that native image can find it. You'll notice, by the way, that native image has a number of flags that we normally see for the JVM. Oh yeah. So here, for example, we've got the standard suite of class path flags. We've got the system property flag or the -J flag to pass a flag directly to the JVM. We've also got the assertions down here, right, for being able to turn on or off JDK 1.4 style assertions. There's also the -G flag to generate debugging information. This is probably the least used Java C flag ever because the JVM has so much information. This actually becomes pretty important when you're generating native images. So I would definitely recommend you do with debug information, at least until you've determined that it makes a performance difference and that performance difference matters to you. Now, some of the other things that Grawl does and some of the other demos you'll see out there really start to home in on some of the performance concerns. So for example, there is a way to generate memory maps of how objects are allocated and deallocated and so forth. That is one of the things that Grawl really wants to do, is help build an ecosystem of tooling that will work across any of these languages, whether it's Java or otherwise. So a lot of the tools that Grawl will talk about, let's see, debugging and monitoring tools, right? Visual VM, and some of the Grawl insight tools to be able to identify where things are going and how they're executing. Notice they're doing it here against the Node app. All of that is stuff that is still very, very much being refined and improved and so forth. If you are a performance junkie, I would strongly suggest you look into this. Also, there is a book, the only book that is out right now for Grawl. Pact Publishing sent me a copy in exchange for a review. So let me pull this guy. In this book, the author spends a fair amount of time exploring those tools and showing you how to generate those image maps and analyze the resulting performance characteristics so that you could take a little bit firmer hand in terms of how your applications behave. I've never been that deep of a performance junkie. A good friend of mine who works at Smartsheet, Ron Reynolds, you know him, Nimrit. Ron would love some of the stuff that Grawl can do in terms of some of the visualizations and so forth. Not something that I personally care about too much, but it's there. It's there if that's what you're interested in, if that's what you're interested in doing. So I would definitely recommend, if you're serious about taking a deep dive, particularly for the performance implications of Grawl, I would recommend the book. If you're like me and you're interested in the polyglot, book's not as useful. I mean, in some cases it's parroting the documentation, which, it was one of the things that disappointed me about the book, was that it didn't really dive more into the Truffle framework. And in particular, I wanted to see him build a simple DSL and compile it with Truffle, and no, he just points to a simple language and we're done here. So let's see, I'm going to pause there for any questions around native image, because I know that this is one of those things that those who get excited by this get really, really excited by this. Nothing. Not seeing any hands.
Just a lot of information to absorb.
Drinking from a fire hose. That's all right. If something comes up, what's that? Go ahead, Nimmer.
Sorry, trying to walk away from my kids watching a video.
No worries.
All right, so yeah, my question is around the native image. So with all these modular support coming on, being able to build and link with the Jigsaw support, is this still relevant?
That is a fair question, and I don't know that I have a definitive answer, to be really honest. I think that if you think about modules less as a runtime construct and more of a way to slim down the JDK before you turn it into a native application, yeah, I think it could be very useful. If you think about, if you're trying to do modules as a runtime construct, native images, they're certainly capable of loading things dynamically, but now you're kind of flying in the face of what the native image was originally trying to do, which was give you faster startup time, et cetera, et cetera. Plugin type scenarios generally are for longer lived applications, application servers, et cetera. I don't know. I really don't know the answer to that. I think it would depend a lot on how you use modules, or if they're just there and you tolerate them, right? Because that's where a lot of Java developers that I've talked to over the last half decade, they're like, yeah, I know we've got modules, but for the most part, I try to ignore that stuff and go back to using Java the way that I've always used it. Now that could just be the crowd that I'm hanging out with too. I don't know.
I agree with you. And actually turning on modules, it's a bigger pain than anything else. Most libraries don't work. And yeah, it's
yeah.
I wouldn't say most libraries. If you use one of these big frameworks that pulls a bunch of libraries behind the scenes, most likely it's going to be difficult to use.
Yeah. So this buddy of mine, Ron at Smartsheet, he's one of their performance architects. I don't know what his title is, but he explored about 2 years ago, I think it was, he was exploring modules for Smartsheet. And because Ron knows that I've been a part of some of the various JSRs, including one of the very early Jigsaw related JSRs, he sort of stormed over to my desk one day and said, "What the hell were you thinking?" And I'm like, "Okay, Ron, where is this coming from?" He's like, what is this whole module stuff? And I'm like, oh God, you're there. Oh yeah. We need to do this over beer, because let me tell you the full story. Java has, in some respects, if the module system had come out a decade earlier, I think we all would have made the adjustment and been happy. But because there are so many different tools out there for doing what are effectively modules, OSGI has been out for decades, and you've got the various different class loaders that different open source project ecosystems have created. And at this point, it's just sort of one additional thing on top of all of that. And yeah, it's the same thing is true of the logging libraries, right? If you're doing something from scratch, sure, go with what comes out of the box, the native module system and the native logging. But so much of what we're doing is not, greenfield. We're building on top. Even if we're building new code for our company, we're building on top of stuff that's been around for a decade or two, right? So this is part of the reason why I was playing around with Graal 8 for as long as I was, because I wanted to see it without modules complicating the picture. And it was pretty straightforward. The fact that Graal seems to be deprecating all of their Java 8 images, little disconcerting, because now everyone's going to have to deal with modules whether they wanted to or not in order to use Graal, which Oracle was always trying to get people towards anyway. They've been struggling for years to force people off of 8, whether you liked it or not. So anyway, I don't know if that answers your question, Rick, but.
Oh, thank you. Yeah.
Okay. Yeah, so again, GU available, just verify that native image is there. It should be. It's, like I said, the biggest thing that people are interested in about Graal. Do the GU install native image, And then, you can actually give the executable a separate name. You can also, when you run it, you see this build artifacts.txt. This will essentially tell you what was created. There are ways to generate. So if we go back up through this list here, you can actually take your Java code and generate a standard operating system shared library. Dilib for Mac OS or a lib.so for Linux, etc. You can also create a completely statically linked executable. In other words, no dependencies on either the runtime libc or zlib. That's if you're, particularly if you want to run on like a Raspberry Pi or something similar where you don't have even, you really want to have a bare bones operating system image underneath. You can also do cross compilation. So theoretically, you could target a different OS architecture. So on here, I could target a Linux, a Linux ARM target, right? Because I'm running on top of a Mac x86. I have not played around with the target. I have not done anything cross-compiler in I don't know how many decades, but theoretically it's there. This, I think, is going to be predominantly for the people who are playing around with Internet of Things, right? If you want to put something onto a Raspberry Pi or similar small scale piece of hardware, that flag, I think, is where you would go with this. And frankly, that's where a lot of, I think, the native image stuff will go. In addition to the serverless, I think a lot of the IoT crowd is starting to tap into this. Java has not historically been a strong IoT player, but native image makes it so, and I think people are starting to pick up on that and start going, oh, so I could take my Java code or my Kotlin code or my Scala code, and then I could pop it onto the Pi without having to have a full JVM there. If, by the way, you make use of any of the polyglot features from the Truffle library, so if my Java code calls out and does some JavaScript, you should let native image know so that it knows to go look for those scripts so that it can embed it as a part of the native image environment. Now, again, this is an area that I have not experimented with yet either. I don't know. I would presume that I could native image my Java code and just have the JavaScript and it would be there and it would be executed. I think what this does is this embeds the language support modules. In other words, I need to have the JavaScript interpreter inside of Grawl to be a part of the native image as well. But like I said, I haven't experimented with, I just point this out because this was something I discovered a couple of months ago and haven't played around with it yet since. Okay. All right. Native image, did through all of this. Again, real quick, I'll point this out. The G1 collector is available if you're using the enterprise edition of the Graal VM. That may be the principal reason to use or to get a hold of the enterprise edition of Graal, is to get a hold of that collector, because that is supposedly the same G1 collector that ships as a part of the Java 1 or the Oracle JVM. Beyond that, I'm not sure that I see a whole lot of differences. I think I said all of this. If you want more details, that's your URL to go to. It's going to take you off to basically one of these pages I think I had open. Well, yeah, anyway. Officially, by the way, native image is still listed as experimental. Lots of people seem to be using it in prod though. Or at least claim that they're using it in production for some of their microservices support, or are close to using it for microservices support. Just do your due diligence here, right? Make sure you take it, generate the native image, and then run it through your exhaustive test suite. Make sure that it handles all of the various test cases you throw at your microservice from an outside perspective, right? End-to-end testing as opposed to unit testing. Before rolling it out into production, because that's just due diligence. Okay. Truffle. Truffle's fun. Truffle is officially what provides the various language implementations for the Graal VM environment. Production ready Java, what they've referred to as espresso, as in the Italian coffee, which includes support for Scala, Groovy, and Kotlin. So really, this should be any JVM-based language, Clojure, Gosu, any of the various Java languages should be able to run as is on top of, if it can run on top of the JVM, it should be able to run on top of Espresso. And there's some interesting documentation here, where they're saying, well, why would we do Java on Java? I mean, why wouldn't you just run the JVM? Because they want to actually do all of the same things that they do for all these other languages in terms of doing some optimizations, doing some of the same kinds of optimizations for Java as they do for Ruby or Python. So they've basically built a subsystem for Java on top of that happens to map very much in a one-to-one basis. JavaScript and Node.js is considered production ready, so you can actually run Node applications on top of Graal. Again, be careful if there's any JS package that has native bindings. That may not connect. And then, of course, we just spent a whole bunch of time talking about native image. That, they don't list it as experimental, the implication being that it's production ready. But I haven't heard anybody from Oracle say, oh yeah, you should definitely use this in production. They're kind of in this weird quasi state. Oh, hello, Kitty. Are you joining us for the meeting? If all of a sudden I jump and say, ow, it's because my cat wants attention, just FYI. The rest of these are labeled as either experimental or visionary, although I think Python made the move up into the experimental category. I believe what they're essentially proving is that we could do these things, and I think they're testing the waters. I think they're testing the market to see how much people will really care about this, or do they just care about running Java code faster? All of this, though, falls under the umbrella of the Truffle API, and essentially it's basically it's one purpose, but it's expressed in multiple ways. The first is as a polyglot layer between languages. We'll see that one first, so that your Java code can call into JavaScript and vice versa. It's also an implementation framework for new languages, and I should add here, new tools, new instrumentation type tools. So if you want to build something to explore what's going on inside of the JVM, inside of the Grawl VM, then they want to give you that ability. And they have a sample language, which I'll show you, and a sample tool, which I'll also show you, for doing that. Again, this is by far and away the least documented of the lot. And this is probably the area that's most desperate for documentation. So I would not dive into this unless you spend some time like building languages prior to now. But it can definitely be a fascinating place. And to me, this is why I think Grawl is the future for the JVM, because this opens up a whole new axis for doing things like DSLs and or new ways of thinking about programming. Brief side tangent. Nimrat, has the Jug seen anything around Ballerina yet? The programming language Ballerina?
No, I don't think I've even heard of that language, actually.
Oh, I may have to come back here next month.
You're welcome anytime.
This is a service-oriented programming language.
Ooh, interesting.
Yeah. We'll have to talk once this one is over, and I may see you guys next month to talk about Ballerina. But there is a couple of these that are emerging, these service-oriented programming languages, where we think of services as a first-class construct. We don't even care so much about objects, although objects are useful. We care more about the creation and exposure and consumption of services. So this, for example, Ballerina currently runs on top of its own virtual machine that runs on top of the JVM. If Ballerina could be rewritten to make use of the Truffle API, then it would be running, quote unquote, on the metal in a Graal virtual machine, which could yield all kinds of interesting performance improvements. that's where I really think Grawl's biggest power is. The native image stuff, I think, is the gateway drug to get you into Grawl. Truffle is, I think, what is the glue that will keep people there as they start experimenting and seeing more of it. So, yeah. So, as Polyglot, if you want to use Truffle, you don't actually have to have Grawl installed to do it. You can, in fact, pull the jars down. They're stored up in Maven Central. Personally, I've been exploring the JavaScript interpreter, partly because like I said, I enjoy playing around with polyglot kinds of projects. I've been working actually on the idea of a game engine that allows module developers to be able to write modules, build scenarios in a scripting language like JavaScript, but the actual underlying code is written in Java. And in this particular case, it was Kotlin that was then being compiled to run as part of libgdx, which is one of the Java gaming frameworks. And all of the Truffle Polyglot stuff is straight up Java code, so it was just working. So if you want to do this from Java, if you want Java code to be able to call out to one of these languages, well, okay, Llvm.polyglot is the package. The .proxy is to pick up the value type. But here, straight up application, right? Here we see some JavaScript code. Now, in this particular case, what we're defining is a function. I want this to, when it's evaluated, to generate into a JavaScript value that is executable. In other words, I want this, whenever we eval this, the return is a ready to execute function. And whoops. And in this particular case, to do this, we instantiate a context. This is a Grawl polyglot context, right? Context.create builds it. And here I'm doing sort of the cheap throwaway thing, which is to say, I just want to take the raw source code, feed it into the context and evaluate it, right? This is just a raw eval. There are no optimizations that are made. It's just executing it directly. I think I pulled that code, yeah. So this will take a few seconds because it's got to pull things down from Maven Central. But there we go, right? What we see is we went ahead and evaluated that, which turned that into a value object from the Grawl perspective, right? That's what we store here in the value. And then when I say value.execute, I pass in this one parameter, and the result is another value object that I ask to convert to a string in order to return it back strongly typed, blah, 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 right? Now, this works for any JavaScript code. I can go in here and change this all day. If I find that I'm going to be doing a lot of JavaScript execution, particularly if it's going to be a larger collection of JavaScript, and I would like to see Truffle do some optimizations, the preferred path is to actually take this and feed it into a polyglot source object with a capital S. So if we pop into the Java docs here, right, this is basically the same thing as what I've done. Generally, though, what I want to do is I want to actually show me a source. Okay. Context builder, frames, give me frames. What I want to show you is this object here. The source object represents the idea of some source code unit. Most often it's going to be a file, right, off of disk. So here I'm going to create a builder to go ahead and, assuming it's this language and this file, right, build that into a source object. At this point, Truffle is able to do a certain amount of optimization for that source file so that we can get some better execution. And so I can execute this source object rather than evaluate the raw text input every single time, right? So for example, what you can imagine is kind of like what happens with Python, when they scan in the source internally, the Python interpreter / compiler, it transforms that into a native bytecode format inside of the Python interpreter. And so from there, it will just execute that bytecode so that it's faster. It doesn't have to rescan the source every single time. It's basically what this source object is doing as well, saying, hey, I want to turn this into a, an object, and there's some optimizations, and it's more of a low intermediate representation, and then I can execute it from the context. Now, the other thing that we typically want to do is we want to bind values. So there was that example here in the context. Yeah, so here, go back to my example. Here I'm passing in this parameter, but if I want to store this as a global, I could certainly say var hello equals function blah, blah, blah. But in some cases, I want the global to be defined in Java code, or I want to invoke that global from Java code. And this is where we get into the notion of bindings. So if I create this context, here I'm creating a JavaScript context, instantiating the JavaScript engine. And then I can say, give me a list of all of the bindings within this particular context. Well, in this particular case, it's going to give us all of the top level bindings of this particular context. And more importantly, I can add to those bindings. I mean, fundamentally, bindings is just a map, but it's going to be a map of names to values, where those values are going to be values understood by the polyglot environment. So here, when I evaluate foo against that context, and then take that resulting value object and convert it to an integer, it should be 42 because that's what we put in here. If you've ever played with the scripting API, the JSR 223 API, a lot of this is very, very familiar because fundamentally, for any sort of script interpreter environment, if you've ever played with hosting the native Python API from C or C++, it's very fundamentally the same thing. We have to be able to parse code. We have to be able to execute that code. We have to be able to pass parameters, harvest the results, and we have to be able to evaluate bindings at various levels of scope. By the way, make sure you close the context when you're done with it, which is why in this code, I put it inside of a try with resources here so that the context can release any of the resources that are associated with it, most of which is memory, right? So I'll pause there for just a second to see if there are any questions. Nothing. Okay, brains are fried. No worries. The other thing we can do is Polyglot runs multiple directions. So if you are running on top of the various flavors of the Grawl runtimes. So again, let's make sure I'm running the Grawl. Yep, here we go. So if we go into here we see some straight up JavaScript code that is going to instantiate an object of Java type, in this case, the big integer type. So if I say Node.js app.js, oops. There we go. It blows up because this is a drop-in replacement. And as a drop-in replacement, there is no notion of this top-level Java binding. The secret sauce here is to pass in the super secret Llvm flag to the Grawl node implementation. And now we can actually do whatever 2 to the 100th power converted over to a 16, whatever that string of JavaScript is for doing a Java big integer, right? So again, part of what Grawl, we obviously come at this from a very, very Java-centric perspective. We think about Grawl as being a JVM. What Grawl is really trying to do is it's really trying to be a universal VM, a UVM, if you will. And so it wants to be just as useful as a JavaScript virtual machine as it is a Java virtual machine. And eventually we think it'll be a Ruby virtual machine and a Python virtual machine in which all of these languages can be equal class citizens. And that's what really opens up some really fascinating opportunities, because, you know, certainly there are things that Python does very well, and there are other things that Java does very well. So why do we keep trying to copy features from these different languages? Why not let each focus on what they do best? Why not let Ruby be a very, very flexible syntax environment? And who cares about the performance? Because if we need something to be high performance, we can drop down to a Java or even a C++ native code, quite frankly. This polyglot approach to things, you know, let's make use of each language. It's actually a very, very old idea, first coined by Karl Marx, who said, from each language according to its abilities, to each project according to its needs, or something like that. I think it loses something in the translation from the native Klingon, but I'm pretty sure that's what he said. This is where the real power of this comes to play in my mind, is allowing, for example, to, you know, if JavaScript is generally a space where developers play, but certainly this is what a lot of your bootcamp graduates are learning right now. They're learning all the Node.js, Node, React ecosystem. Rather, you know, if your company is currently standardized on top of the Llvm stack, don't force them to learn Java. Let them continue to write JavaScript. Just teach them this little trick to get them to use those big complicated objects or classes that do all of the heavy lifting that your company does. Let them go ahead and continue to write and run in JavaScript. If you've got some data scientists who are doing some analysis and have written some very complicated analyses in Python or R, don't force them to rewrite it. Don't sit down and put a whole bunch of effort in trying to do compatibility testing, unit testing to what they've already written. Just consume it as is on top of this universal runtime. It really opens up a whole variety of options, including from a straight hiring perspective. Because now, theoretically, if I go out looking for senior full stack Java developers, I mean, it's not like they're just hanging from trees waiting to be plucked, right? But if I can hire some JavaScript developers to work as juniors on the team with the full stack Java developers, and they're all running inside of the same environment, running code that can run on top of the same virtual machine, that opens up some possibilities. It adds, like I said, a whole new axis to this whole, you know, where do I find developers and how do I get them to work successfully together? Then we get to the part of saying, hey, I want to create my own language. And this, I mean, you know, I already knew I wouldn't have time to go into this to any length or degree. The Grawl folks have created a simple language, which they call simple language. The artifact that they create is SL. And the GitHub for it is here. And so if we go into the language and we look at some of the tests for it, let's see, we define a function here. As you can see, essentially it looks vaguely JavaScript-esque, function, foo, parens, println, et cetera, et cetera. This is a language that's fully defined and implemented in terms of the Truffle framework. This is what they point you to by way of documentation for figuring out Truffle. There are some docs. It's very, very annotation heavy. They are doing some significant optimizations in places to try to, you know, to make the generated code run as fast as it can. But fundamentally, it starts from you parse to an AST, to an abstract syntax tree, and then from there, Truffle can take over and figure out the execution and or generation of code. Now, if you're not sure what an AST is, that's okay. This is not where you want to start. It just isn't. You want to start with figuring out how to parse and execute an AST. That's your first step. Pick up a copy of the Dragon book or any of Terence Parr's book on language implementation patterns, etc. As a matter of fact, the language, if I'm not mistaken, if we go into language source parser, yep, there we go. We see that they've defined the language in terms of an Antler grammar, right? So if all of this looks familiar and makes sense, then cool. By all means, dive around and play inside of here. If it doesn't, I would wait for the first raft of books to come out. And, you know, by the way, Adam, if you've ever thought about writing a book, if you figured out Truffle, the world desperately needs a book on how to build an implementation of a language in Truffle. Most of what they say is, let's see, ID setup, Eclipse, run, dump graphs. Somewhere in here, they basically say, the best way to do this is to just grab this project and start hacking. Yeah, we have found the easiest way to get started with implementing your own language is by extending an existing language, such as simple language. So in other words, we don't really want to write docs. We just want to point you at code and let you hack. So definitely this is part of what I'm experimenting with over the holidays, because everybody needs to have a good holiday side project when you need to get away from your family. Make sure they're not listening. Similarly, the simple language, these are just some slides explaining what SL is and how it operates. So here we see main, here we see the idea of, this is a very simple dynamic JavaScript-like language. We new up an object, we add a field function referencing this function out here. Lo and behold, we now have an object. Presumably, if we wanted to do inheritance, we would create another field called prototype, blah, 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 blah. The key thing is Antler will do the parsing, which then gets converted into nodes. And then from there, the Truffle framework takes over. And yeah, Adam definitely is right. It's not simple. You really want to be comfortable with Antler before you start diving, because they've actually customized part of how Antler works rather than just take the generated Antler code as is. So this is definitely not a place for beginners in terms of language, but if you've spent some time doing language implementations in the past, even if you've just tinkered with them, you know, definitely recommend, because I really think this is where the long-term payoff will be for Graal VM down the road. Similarly, there's a tool implementation framework, what they refer to as instruments. Truffle Instruments, I believe, is the quoted name for it. And this is all the things you would normally have done using any of these interfaces: debug interface, toolkit interface, profiler interface, etc. For example, one of the things that I've always wanted to do is create a sort of universal trace tool, so that when I fire up my application and run it, I could turn on, hey, I want to see, I just want to capture data from the JVM, not from a profiler perspective, but from an audit perspective or from a debugging perspective. For example, if the application dies before I ever, you know, get to the execution of main, pretty clearly something threw a class cast exception somewhere. But it's hard for me to set a breakpoint or know where to set a breakpoint when all I get is this exception that came out of nowhere. So what I'd like to do is build this trace utility that will just start capturing information and dumping it into a CSV file or into a, you know, a straight up text file with events in it and so forth. And then be able to tune what exactly I'm seeing as I'm running it, et cetera, et cetera. You know, very simple. There are certainly some commercial tools out there that would do that, but I wanted to build one myself using these interfaces. Well, today, if I want to build that for the Graal universal platform, I would do this as a Truffle tool, which again, they have a tool example, and this is much newer. This wasn't here when I looked at Graal about a year ago or so, maybe a little bit longer. Looked through the docs comprehensively. This wasn't present. Looks like they'd been working on it for 2 years, and then probably in the last year or so added it to the documentation set. That, or I'm just blind. But this is a very simple code coverage tool. And again, this is a universal runtime. So this code coverage tool can work for both Java code as well as for any other language that runs on top of the Graal VM. So we could do this for JavaScript, we could do this for Python, Ruby, et cetera, et cetera. Again, not simple. It's just probably the simplest that we can produce, right? So if you're interested in building tools, if you're interested in trying to see what events the Graal VM will fire at you, et cetera, this is the place to start. Because again, very little by way of documentation here, right? Implementing your tool. They talk a little bit about the API here. It's very, very high level. They talk about the events that get fired, how to register your tool at runtime, implement the event listeners, et cetera. So again, you know, Graal is a place that's ripe for exploration and experimentation. There are likely to be a variety of books that will come out around Graal down the road. But this is very definitely virgin territory. There's not a lot of people who have tromped around out here. So if you're looking for a place to, you know, explore, to do something that not everybody knows, if you're looking for a book to write or conference talks to give, Truffle is definitely high on my list. Chris Seton, by the way, you definitely want to take note of this name. He was involved in Graal very, very early on. I think his doctoral thesis actually is really, really interesting read. He created a language called Katahdin, which allows you to define language syntax at runtime. Is actually built on top of the mono.NET implementation. And this was before he jumped over into the Ruby world, which is what got him into Graal. And then now he's currently at Shopify. Shopify does a bunch of Ruby stuff internally. Chris is a sharp dude. I would highly recommend you read anything that he has written. But bear in mind that a lot of what he has written was for the academic community. There are a number of videos that are available. Usually these are conference presentations. But you know, this is the list of materials that are available currently until people go off and build more. And this is me, if anybody cares, but nobody does. So, any questions? Okay, then, Jonathan, I think we're done here.
Cool. Thank you very much.
You're very welcome. Thanks for having me. And I imagine you, me, Nimrit, and Freddie will talk about Ballerina for some upcoming JVM CJUG conversation. I mean,
Deal.
Yeah. It's the world. The world is at the moment salivating for a service-oriented language. They just don't know it yet. It's very much in the same. We're very much in the same headspace as we were right around the time that Windows 3 was shipping and we were writing Windows applications using C, or right around the time that we started building server applications using C++, and we didn't realize how badly we wanted garbage collection. It just feels like we're at that point where somebody's going to come out with something and it'll be like, oh my God, this is totally what I needed. And the Ballerina folks, this is from the same folks that do WSO2, which was a bunch of the web service standards folks for a while. They are trying to put this as that candidate. I'm not sure if it's quite there yet, but if it's not this, it's going to be something that's somewhat similar. So,
by the way, I have a quick question, slightly unrelated. On GitHub, what extension gives you the buttons for the like IntelliJ products, or the JetBrains products, like IntelliJ IDEA, WebStorm, and so on? Like next to the clone button, if you open a GitHub tab.
Oh,
and go
so
to the
go
root of the repo. Yeah.
These?
Yep, those. Those are pretty cool.
I don't remember. I think it might be the JetBrains toolbox did that.
Oh, it does it for you. Okay.
I think. I'm not positive. They showed up one day and I was like, okay. Because I did a brew cask install of, I think I did a brew cask install of the toolbox on this machine. Let's see. Is this? Yeah, it's the JetBrains Toolbox extension, which I think gets installed when you do the JetBrains Toolbox installer. Yeah,
Nice.
Jarek posted a link to the chat, which looks like it's the description of this extension. So
Cool. So thank you very much.
thank you.
And yeah, that was a great talk. And hopefully we'll see you with Ballerina sometime soon.
Yeah, I will not wear a tutu. I'm just telling you now.
I believe you can live with that.
Yeah. All right. Thanks all. I'll talk to you soon.
Thanks everyone, and have a great night and goodbye.